Okay, guys, this is 7.7, which is really Kurt's 8.1, and unfortunately, it is a lot of vocabulary. Yes, I made my changes to the notes, but unfortunately, it may not be very short, so let's get right to it. I'm going to start out with try to get you all the words that you need. I would start on your next available page, and I would just keep going until you finish. So 7.7, which is really 8.1, and it's Intro to Quadratic Functions. The very first thing that we're going to talk about is what is a quadratic function. So any function that can be placed in the form of y equals ax squared plus bx plus c is a quadratic. So let's write that. I don't even know if I can fit this. Any function written as y equals ax squared plus bx plus c, where a cannot equal 0. Everybody else is allowed to, but a cannot equal 0. Okay. What is a parabola? We've talked about this before. The graph of a quadratic function is called a parabola. Quadratic function. It's often described as a U-shaped graph. Okay. Look below, we have parabola examples. You notice that in many of them, and I'm not asking you to write all of this, but it would be good if you could just show how there are many different types of examples. So in Kurt's video, you notice that he talked about very skinny parabolas. He talked about very wide parabolas. And these are all showing those types of things. You can even have upside down parabolas. So I just thought each of these boxes were interesting. Each of these graphs are interesting. So sketch them to the best of your ability. These are parabola examples. So notice how with the yellow one, we have a 2x squared. And then when the 2 is taken away, the light blue one is just x squared. It's a little wider. And then when it's dark blue, it's because the leading coefficient is 1/2 x squared. So you can see that the leading coefficient is what causes the width of the parabola to widen or narrow. And then notice here, if you can check this out, it's a little light, but see how it's negative x squared? That negative on that leading one is what caused this parabola to open down, okay? So as soon as we get into more challenging parabolas, we notice these quadratic functions, they have more on their function, on their equation. And the more involved the equation gets, the wider and off-centered. See how this vertex point here is not centered. It's off to the side. It's pointing down. These are all characteristics of, these are really like the characteristics that result from the different parts of the equation. And then this is a really interesting diagram. It just shows the different colors. I know you can't read it. It's so hard to see, but just showing how the equation is affected when the leading coefficient is 2 or 3 or 1/2 or 1/3 or negative, and they start to either point up or down. But because all of these have plus nothing at the end of them, that's why they all start at the origin. All their vertex points are at the origin. So we'll get into that more. All right, parabola's turning point. Well, parabola's turning point is the vertex and also referred to as the minimum point. So we're just going to write vertex and minimum point. Okay, the axis of symmetry. It's the line that travels through the middle of the parabola and its vertex point, or in other words, turning point. So let's see if I can do this. Let's give a little example off to the side. We'll do a gray coordinate plane. We'll do a blue parabola. And actually, let's move that over a little bit. Let's make it a little off-centered. And then the axis of symmetry, if this is the vertex point here, the axis of symmetry is the line that cuts it right down the middle. And you're very often asked to give the equation of the axis of symmetry, which won't be difficult for you as long as you know what the vocab word means. So let's describe this as the line that we could shorten this, maybe say that cuts the parabola. No, I really want to say that travels through middle of parabola I'm going to leave it at that because we don't have enough room. So the green line here in this example is the axis of symmetry. All right, let's switch colors here. So the zeros, what are the zeros? The points where the parabola crosses the x-axis. Let's say points where parabola crosses x-axis. There can be one, none, or two of these. So these are also referred to as the x-intercepts, which we'll talk about. Let's see. Okay, standard form. We've seen this before. When a polynomial is placed or arranged in ax squared plus bx plus c form, and that means it's simplified and in descending order. So standard form, I'm just going to write ax squared plus bx plus c. It's got to be simplified, so no like terms, and it's got to be in descending order. Okay, linear coefficient. Let's switch back to a different color. So the linear coefficient, if you're think about the standard form, ax squared plus bx plus c, the linear coefficient is actually the b, so the number that b represents in the bx term. That's what we're going to write. That's a pretty short and sweet way to do it. Then we move on to, I lost my spot. Constant. Okay, so thinking again about ax squared plus bx plus c, the constant is the c in standard form. And that's c is representing a number. And it's a number that does not vary because it's not multiplying a variable, so it doesn't vary, therefore it's constant. So it's the c in standard form. Let's switch back to blue. And then we have leading coefficient. So the leading coefficient is actually the a in standard form. And that's about the shortest way I can describe it. The longer way to describe it would be the first coefficient of the polynomial or quadratic when it's been written in standard form. So we can write part of that. Let's write the first coefficient. Oh, geez, spelled it wrong. Coefficient in standard form. Okay, pause the video if you need it. I got to move on so I don't run out of time. Okay, we've got some review vocabulary. Linear function. If we think about a linear function, hopefully you're thinking of y equals mx plus b. Oops. And where, let's see. Let's just leave it at that. You know that. And the input, of course, is the x values or x coordinates. The output is the y values. I'll switch some colors here. Y values or y coordinates. The x-intercepts, again, we know the definition of x-intercept. It's the point where the graphed image crosses the x-axis. But here we've talked about a little more about an x-intercept, and that's that it's really, all the x-intercepts are referred to as the zeros when it comes to a parabola. So we're going to write, again, the point. Actually, let's write it out. The point or points where the graphed image crosses the x-axis, also known as the zeros, okay, which we said once already today. Actually, let's get